First and foremost, with doing any magnet inspection, the magnet must be fully de-energized by touching the leads to the case to de-energize any stored energy. The other consideration is to not ever position yourself underneath the suspended load of the magnet during inspection of the bottom carriage. First part of identifying the magnet you're going to be inspecting is getting the data off of the data tag that's welded onto the magnet. Also, the model, size, and model of magnet is actually usually welded on the top. In this case, it's a 58-inch SDC. We then take the temperature of the magnet. This will allow us to determine the base temperature of the magnet that could possibly affect the coil resistance readings. Once those temperatures are recorded, you can see here the surface temperature is 62 degrees, which is basically room temperature in our shop. We then set up the multimeter to take the resistance readings at the studs located inside the magnet junction box. We're using a Fluke multimeter set to the ohm resistance setting. Here's another example that we're doing on a different magnet. Notice we're reading an open off of these leads. That's indicating that the magnet has a coil issue. Not all magnets have wire lugs inside the junction box. Some magnets have terminal plugs with copper studs. We also can check these for resistance readings on these style magnets. The next test we do on the magnet is what we call a Megger test. Meggering tests the insulation values or electrical resistance to ground of the insulations inside the magnet. We use a Megger meter here. The proper way to use this is snap the hot lead onto one of the leads, coil leads inside the junction box. The other lead gets snapped to the case after cleaning it thoroughly. We then set the meter to 500 volt. We push the test button and we read the mega ohm reading of the internal insulation. A good mega ohm reading is any reading greater than 200 to infinity mega ohms. A bad reading will be less than 200, which indicate the magnet has an internal issue. The next section of the magnet inspection program is to check the mechanical components of the magnet. In this case, we're looking at the lifting lugs and chain pins for wear, and we check around the pin circumference, the retaining washers on the end of the pin, and we do that at each location, looking for wear on both the pin and the ears. You will see wear, which is indicated by an oblong hole in the ear, any excessive wear in the chain bail or lug area, and also the D-ring shown here. The next step of the inspection process is the undercarriage of the magnet. If we can get the magnet up off the ground and inspect the bottom center pole, outer pole, and bottom plate, which is the most important part of the magnet, which does most of the work. As you can see here from the video, the center pole is very mushroomed. The welds look to be intact. The bottom plate does not indicate any damage or dents. The outer pole is in fairly good condition. However, we do find a crack running longitudinally along the outer pole of the magnet, which would need repaired as part of the mechanical repair process. This particular magnet is a drop ball magnet, which has bolted studs that run down to the center pole at the bottom of the magnet. These bolts can become damaged or broken, and a good way to check those is to hit them with a hammer and to hear the difference in the sound. A dead blow hammer will not work. You have to use a solid steel hammer to do this. The final step of the inspection process is to inspect the lifting suspension chain. You want to check the D-ring portion of the chain for excessive wear in both corners. You also want inspect the master links that attach to the D-ring and the full body of the chain links. Notice the wear in the bottom oblong link. This is the link that attaches to the magnet chain pins. It has excessive wear and must be noted on the inspection report. Finally, at the end of the inspection, please list any remarks or recommendations that you may have for